Hello, this is Eddie from RoboThink. Today we are going to build a gear ratio tester. The purpose of this gear ratio tester is to demonstrate the applications of gear ratios and how gear ratios affect the speed of the input crank versus the output shaft, right? So let's begin here today. Let me build this gear ratio tester and I'll do an explanation of what this gear ratio tester does at the end of this. Okay, let's begin. Okay, this is a gear ratio tester. Let me demonstrate what this does. Okay, let's see the series of gears available here. Okay, let's look here. This is the input crank that's connected to this axle, and from this axle it drives two gears, which is the small gear over here and the larger gear over here. Okay, what this does, this small gear drives the large gear over here, which in turn turns this axle that is connected to the black cell, whereas the large gear here turns the small gear, which is connected to the axle that is connected to the red cell. Okay, let's see what happens when I turn the crank. Do you notice that the black cell turns at a much slower speed than the red cell? Okay, why is this so? This is because the black cell is connected to the large gear, which is then connected to the small gear here. Right? When this small gear drives the large gear, the speed will become slower. Okay? And when the large gear drives the small gear here, which is connected to the red cell, the speed will be faster. Okay? How fast the speed goes depends on the number of teeth on each gear. Okay? On the small gear that we have here, there are 12 teeth, and on the large gear there are 36 teeth. Right? So what this means is that the small gear will turn, when the large gear turns one round, the small gear will turn 3 rounds, because 36 divided by 12 is 3. So if you notice here, okay, let's try here. Okay, both are down. Let me turn one round of my crank and see whether this red cell turns 3 rounds. 1, 2, 3. Okay, I've turned one round of the crank, but the red cell turns 3 rounds. Okay, how about the black cell here? Okay, it's connected 90 degrees here. Let's try to turn one round of my crank. One round. It just turns 1/3. Let's do another round. It turns the other third. Third round, it goes back to where it was originally. Okay, so what this is doing is that the small gear over here turns, for every round that this small gear turns, this large gear only turns 1/3 of the round, because there's 12 teeth here and 36 here. So it needs 3 times of the 12 to turn one cycle of the large gear. Okay, so which means that I need to turn this 3 times for this black gear to turn one round. That's all for today. Thank you very much. Thanks for watching. See you next week.